So guys, if I ask you what is the inverse Laplace transform of cot inverse function, then what is the answer? So here in this video, I'm gonna teach you how to get the inverse Laplace transform of inverse trigonometric function, and that function is cot inverse of something. So let's see. So here we have to find out the inverse Laplace transform of cot inverse of AS. Now guys, how to get the value of this? So here I'm going to use the property, because the inverse Laplace transform of cot inverse of or the inverse trigonometric function is not possible directly. So we don't have any formula available in Laplace transform or inverse Laplace transform which can give us the value of this cot inverse directly. So guys, here let's see the property. So as per the property, the inverse Laplace transform of phi of s is given by -1 by t into inverse Laplace transform of derivative of that phi of s. So here guys, in our question, this is my phi of s. I'm going to find out derivative of that and we are going to get the answer. So here I'll say, therefore, so it is equal to -1 upon t Laplace inverse of, then derivative of this. So what is derivative of cot inverse of s? So it is -1 upon 1 plus square of this, that is a square s square into the derivative of this as, which is a. Next, this minus a I can take it outside, so that will become a upon t, and here we will get Laplace inverse of 1 upon a square s square plus 1. Now guys, to get the inverse Laplace transform of this function, we have to do few adjustments. So what I'll do is, I'll divide this denominator with a square and I'll multiply with a square, because a square is a constant. So if I multiply it with a square, here I'll get extra a square term. So here I'll write it down, a upon t into 1 upon a square. So this is what the multiplication to the denominator with a square. Then L inverse. Now I will divide with a square. So s square will remain as it is, and this will become 1 upon a square. Now a and a cancelled, so we will get 1 upon 80, and here if you see, then it is matching with one of our formula. So that formula is 1 upon that constant a, which is 1 by a into sine of 80, that is here a is 1 upon a into t. So if we'll readjust it, a and a cancelled, so here we will get 1 by t, and this term will become sine of t upon a. So I'm sure that you have revised the formula of inverse Laplace transform. So by using the standard formula of inverse Laplace transform, we got the answer as 1 upon t sine of t upon a. So this is what the inverse Laplace transform cot inverse of a is. Thank you very much.